Hello and welcome back to another Craig and Dave Unscripted. So if you watched us last week, you will know that we announced someone or a group of someone's has solved the Craig and Dave Cryptic Challenge. We're actually going to have them on in a few weeks. It's a selection of sixth form students and their teacher. We started last week to actually lift the veil, and we explained what the Cryptic Challenge was, where it came from, and we walked through sort of the first part. And we promised this week we'd kind of pick up where we left off. So we're going to do that in a minute. And if you're curious and you haven't seen last week's video, obviously you can go back and watch them. But before we get into that, Dave, I believe we've got a special shout out. Not the one of these in a while.
Yes, indeed. We have a special shout out. It's a belated happy birthday, actually. I wish we'd have done this last week, but because we record these videos in advance, it's not always possible. But yeah, we do like to give a shout out occasionally to those teachers that are making a difference to their students. So when students write to us from time to time and they've got some kind words to say about their teacher, we like to do a shout out because we're passionate about teaching computer science, and we know other teachers are too. And when you can instill that enthusiasm for the subject in your students, it really makes the lessons just so much more enjoyable to teach and so much more enjoyable for students to learn. So yeah, this is another one of our special shout outs. So this week, I'm just going to check my notes here. This week, it's for Mr. Martin. So Mr. Martin at Alcester Academy, and this is a shout out from Oliver and the class of 10D Computer Science. So it's a happy belated birthday, and thank you from us and thank you from Oliver and class 10D for your enthusiasm for computer science. I get the impression that the students like being in your lessons, and they wanted to have a special shout out for you from us. So we're glad that you enjoy some of our content and our resources, and we hope every success for 10D and other classes, and hopefully you'll continue to enjoy working with Craig and Dave. So there we go. There you are, Oliver.
Marvelous. Yeah, it's really nice doing those. I know we joke and do them all a bit flippantly, but the fact that students reach out for us to give shout outs just goes to show how some of those teachers are inspiring their students. And I think we maybe have touched on it before. We talk a lot on this channel, don't we? I've got sidetracked now, Dave. You've made me think. We talk a lot on this channel about research and pedagogy, and the fact that we think about what goes into our resources. But it's no surprise to any good teacher out there that research says that one of the highest things you can do for a student's achievement is working on student-teacher relationships. If you can crack that student-teacher relationship, be a friendly teacher, not be their friend, all that kind of stuff, then that's half the battle, isn't it? That's half the battle. When you're enjoying it, they're enjoying it, and when you enjoy, that's when you learn. So we throw all this research in, but at the end of the day, have some fun with your students. They will enjoy the learning process. So it is really nice. It is nice when the odd student or even class reaches out. Oh, we've been with them for 4 years in GCSE and A levels. We're going to leave. We're gutted to lose them. They've made me do computer science degree, and so yeah. We joke, but they're really nice. They're really nice to do, and we're glad to do them occasionally, aren't we?
Yeah, I mean, let's face it, if every single school that's using our resources wrote to us, I think we'd have a bit of a problem, because we'd be spending weeks and weeks just doing shout outs on our Unscripted. But from time to time, if they come in occasionally, then
oh yeah, that's right. One of those rolling credits at the end of the episode, and we'd like to thank the following teachers. There you go.
Right, that's right.
Pause the video, spot your name. Right. Anyway, so, go on.
Anyway, yeah. So this week we're going to be looking at part 2 of the Cryptic Challenge, as you've already introduced. And last episode, I said to the audience, if you'd like to give us a few comments about the direction of travel for this, we can either look at more of the sort of stage 1 puzzles if you want to, or we can just sort of get into stage 2, which is what we intended to do. But we thought we'd see what the feedback was. Well, we haven't really had any feedback other than big up Craig and well done Dave and all the all the usuals. So,
we're going to crack on.
So we'll just crack on with part 2, and hopefully we're not just talking to ourselves.
That's fine. Right. So do you remember where because I designed this and Dave had very little sight of it. Do you remember where part 1 ended? How that culminated? Did you remember?
Oh dear, this is going to be an episode of putting Dave on the spot. I think I think basically what happened was if you solved 15 of the challenges, because one of the challenges was really just an introduction to what this was all about. So you had 15 challenges. Each one of those, as I remember, gave you an alphanumeric character that you appended onto a web address that you were given in the sort of first task. And if you went to that mystery URL, it would then say, hey, well done for solving the first 16, but that's only stage 1. Now you've got to get to stage 2.
Yeah, so we kind of rushed this at the end. So I'm going to pick up from exactly where you said. You're right. So 15 challenges. And if we remember from last week, all very much embedded in computer science theory, albeit sort of top end A level. We made them challenging. You had to solve all 15. You had to find them all. You had to get exactly the correct letter and number. You had to put them in the right order. And if you did, this is the web page which appeared. And that's kind of where we left it. So we scooted over this quickly last week, but there's a bit of a bridge between part 1 and part 2. So you hit this page, which is a big Craig'n'Dave logo, bit of mystery Morse code, and the Morse that's working this week. I don't know why it wasn't last week. And the Morse code translates into click the tip of the third spear, which is a bit arbitrary. Is it this third big spear, third little spear, clockwise, anti-clockwise? I was like, they'll just have to keep clicking until they find out. Or, of course, they can inspect the source code and see if they can find a hyperlink embedded, view page source. And I'm curious when we get these students on to see if any of them did any little workaround or clever little things. You know, I'm happy with that. So you click the third spear, and that took you off to a totally separate website. It was a separate domain that I'd registered. Nothing to do with Craig'n'Dave at all, because I didn't want people using clever little crawlers or scripts to look through our site XML map and find everything. So this was a domain that had nothing to do with Craig'n'Dave. That's all they got. That was it. Spinning logo. So I guess the first thing you'd do is click on it. And as soon as you did, it took them to this page. Not a lot on any of these, and that's obviously deliberate. So this page had 2 buttons, download and play me. And I'm just going to fast forward through this, but the download gave you a PowerPoint file that had a single slide, which was black with a very dark grey omega symbol filling the whole page. That was it. That literally was it. And the play me is a little WAV file that actually plays in the browser. And the WAV file is, once again, a bit of a 10-second clip of Morse code. And again, I'd be curious to see what the students did here, whether they ran that through an online Morse code thing or skipped that completely. But effectively, the Morse code said, cropping hides the truth. And then if you go back to the PowerPoint, click on the image or double click on the image and go to crop, you notice there's a hidden part of the image because I've cropped it. And the hidden part of the image is a URL. And that took them here. So there's a bit of a bridge there, a little bit of a kind of a bridge, but effectively they end up with another appearance from our mysterious man, who, if you remember, first appeared at the very beginning, telling them to solve the 15 puzzles. And what I wanted to achieve here is I wanted to hope, well, my hope was students thought, right, I've solved all 15 puzzles. I've gone to the secret website of Unscripted, and I've won. I've found the mystery man. I've beaten the challenge. No, monsieur, you have not. So this is what happened next. I'm just going to play this for you now, full screen.
Congratulations on making it past my challenges and getting this far. You have proved yourself worthy to me and are ready to hear the truth. I have been hired by Craig'n'Dave to hunt down the very best problem solvers, the elite computational thinkers, known as Omega level candidates. Making it this far is only the start of your journey. Can you solve all my challenges? Do you have what it takes to become the first Omega level candidate? Many have made it this far, but none have succeeded.
Ooh. Well, that's a lie, because some have succeeded now. So I mean, that was a gag for me. Again, I'd be curious to see what the students think, because the merry-go-man eventually turns around and says, "You haven't won. What you've done is you've proved yourself worthy to take on the challenge of becoming the Omega candidate." It was just
I know what the students think.
And who is
but I'm
this?
not going to repeat it here.
No. Hey. And who is this mysterious man? Does anyone have any ideas? It clearly can't just be Craig in a mask. So yes. So I'm hoping when we get the winners on, they'll be like, "Oh, we thought we'd solved it, and we've just discovered that actually we've proven ourselves worthy to take on the challenge." And the mysterious man doesn't say anything else. So previously, obviously, he said hunt down Omega symbols, find challenges, but he doesn't give them any instructions. This officially launched part 2 of the Cryptic Challenge. Scrolling down, there's one other asset on this page, which is a fractal image. And a button at the bottom says view full size original. Now, I'm not going to click on either of these. That is actually a 20,000 by 20,000 pixel bitmap, Dave. It's 51 meg. And I'm currently working, as you know, off my laptop because my computer's being serviced. So if I attempt to click that image now, it will very slowly render an enormous image. So I'm not going to do that. Students also have the option to click view full size image, and that actually downloads the raw bitmap to their computer. But essentially, that's obviously zoomed out. At full resolution, that image is enormous. You have to scroll sort of 5 or 6 screen widths left and right and up and down. And what did I do? I buried in that image 6 URLs. And of course, they're embedded in the artwork of the bitmap. So there's no clever cutting and pasting or viewing source. They're buried in there. So in there, you're going to have to trust me, they are there. And this resolution, they're tiny. I happen to know, for example, there was one like here on this little spike, and on this image it's probably about a few millimeters across, and of course it's colored just off red as well.
So Craig, you say that if you viewed the source you wouldn't see the link. So how's that link working? Because I'm guessing if I've got a screen reader or something, I might be able to discover them. What's the accessibility on this?
No. So hands up 100%. Yes, we probably aren't meeting accessibility requirements here. There are no links on this page.
Okay.
And you know, one thing we will do in challenges going forward, as we've said, we're going to make them available to schools to download and use. Yeah, as we'll take all of that into consideration. But here, you're right. There are no links on this page. So you cannot do view source and dig out 6 links. The links are written into the image as part of the bitmap. You have to find them, and then obviously you have to follow those by typing them into a web browser manually. I thought about that when designing it, and part of me was like, well, you know, we must obviously take accessibility into account. And I was like, well, I'm hoping people will solve this together. I really hope this will be pooled. It'll be groups of people with their teacher. So you're right. There's no cheating with this one. You can't just view the page source and grab them out. So what I'm going to do now then is I'm going to assume. Now I don't think you know this next part at all, Dave. I'm going to assume you've blown that image up to maximum resolution. You've hunted around. You've found the 6 URLs. You've typed them in, and what you'll have is 6 new web pages. And I'm just going to show them to you, Dave, and see if you've got any clue what you might do. And if not, I'll just explain it. So, this, and like and like before, I numbered the pages. So this is page 1 of 6. So it doesn't matter which URL you found first in the image, you knew how many that you were looking for. So that's page 1 of 6. I'll just flick through them briefly, and then we can go back. That's page 2 of 6. That is page 3 of 6. Dave's just slowly taking some things in. That is page 4 of 6. Oh, there's a hint on that page. That's page 5 of 6. It's a map of some fantasy setting with a grid. And that is page 6 of 6.
Okay.
I do not expect you to solve this live on the recording in 3 minutes.
Right.
But you want to have
Yeah, I won't solve it, but I'll tell you my thought process.
Go on.
So,
yeah.
I was going to dive straight into this, and I was waiting for you to pause, and then you said, "Oh, I'll just show you page 2 and page 3." So I'm thinking that they're all related in some way, and I'm beginning to think that I must know some clues from one thing to another. So I'm looking at this, and I'm thinking, well, I'm recognizing what looks like sort of plus and equal signs, and therefore I'm recognizing what is probably a minus sign. Originally, I thought, well, maybe the little dots underneath some of those characters are representing numbers possibly, and if I knew the number, then maybe I can work out the other numbers. But I'm just kind of looking at it and thinking I probably don't have enough information. So if we go to another page, go to page 2 for me a minute. Right. Yeah, I don't think I've got enough information to do anything with this at the moment. So let's go to page 3.
Okay.
Right. Page 3, I think, is useful. Page 3 allows me to match symbols on the top with letters on the bottom if I just sort of follow the kind of kids doodly sort of, thing. So I think I can use this page to translate the symbols into letters, and underneath there is a load of symbols. So maybe that is some instructions or something. It looks like it's text. Let's put it that way. So I'd probably work out what text that was. Let's have a look at the next page. All right, this one I think is pretty straightforward. If we scroll down, we've got rotate anti-clockwise 90 degrees. So I'm guessing I take that entire image, rotate it 90 degrees to the left, apply the previous lettering that I was given to this as well, maybe, and see kind of what I get. I don't know. Let's have a look at the next one. Right, so I'm guessing if I kind of work all that out and I get some text, perhaps it tells me a grid position on this map. Maybe. I'm just thinking, well, come on, if I've got letters across the top and I've got numbers down the side, it looks a bit like a treasure map. I'm guessing one of these cells probably does something for me, but I don't know which one because I haven't worked out the other clues. Let's have a look at the next one.
Oh, so I'm on the wrong page. There we go. Yeah.
Okay, and I can't really read that if I'm honest, but is that either text or URLs or something? I can't really see what it is.
So they are the little funny symbols that you use, the child squiggly thing. That's what they're made up of.
Ah, right. Okay. So maybe I was wrong in the previous step. What we've got here then is if I apply my sort of alphanumeric, conversion from the previous couple of clues to this, looks like it could be superimposed on the top of my treasure map because I've got the letters again across the top, I've got the numbers down the side. I think the treasure map probably has something to do with this. So I can't solve it, but my train of thought is to try and work out what those symbols are by using the little doodly thing. Having worked out the doodly thing, I can then probably work out what some of the sentences are. Maybe it gives me a clue to what the numbers might be on the first challenge, which then tells me what number I need on this challenge. That's my thought process.
Well, you know what? Oh, I've gone too far. That's not a bad stab for 5 minutes there, Dave. There's just one other thing. What do you reckon? What do you reckon this is at all?
I don't know.
But if I tell you that's a profile of
is it a picture? It's quite small. I'm struggling to see it. Is it?
Yeah, sorry, it is. That there is a picture.
Okay.
Yeah. It's a side profile picture of a famous Roman emperor.
Right.
It's a particular Roman emperor, Caesar.
It's a Caesar cipher. Right. Okay. It's a Caesar cipher. So I'm shifting some letters somewhere. Okay. I'm shifting left. I just don't know how much, but I know how much because of the calculation at the top. It's one number divided by another minus another number. It'll tell me how far to shift it, probably.
Right. You know what? You've done pretty well for someone who had that thrown at them in 5 minutes. I'm curious what the kids did. I'm going to unshare that screen a second, and I'm going to bring up my working solutions file and just explain what I did there. One moment. I will just not use presenter view. Right. And I'll share that screen.
Hopefully.
So the crux. Sorry.
No, it's okay. We've got a bit of lag
on
your end, but it's because of your laptop. It's fine. Don't worry.
Oh, sorry. So the crux of this was solving the number system. Now, this is where we start to take a bit of artistic license, because the first 15 challenges were firmly based in A-level computer science. But having made them quite extreme examples, I thought if anyone cracks all 15, they're logical problem solvers. So this is a number system, and it happens to be a base 25 number system. That's just what it is. And of course, they'll be used to different base number systems, having done base 2, base 10, base 16. And you were exactly right, by the way, when you mentioned, let's see if it's in here. Yes, you were exactly right about those equations. You said you wondered if those equations allowed you to work out unique numbers. And they exactly did. And there were just enough numbers in there for you to work it out, because you were given 1 and 4, and therefore you knew 5.
Right. Yeah.
Knowing that's 5, that means that's
5 minus 3.
5
yeah.
minus 6. Now you know what 2 is. So you were spot on, actually. You had just enough. Now, those equations only on that screen there only allowed you to work out the unique symbols 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which may lead people to believe it's a base 10 number system, but it's not. Because when you end up looking at the big equation that you get there, you see symbols you haven't seen before. So it's like, well, I've worked out the first 10. On several slides, there were hints, as you said, there were hints, but they were written in a weird language, which we used the squiggly thing to translate. And the hints, there were 3 in total. There were only 4 unique symbols. And indeed there are. All other symbols are made up from these 4 symbols. And the number system operates around a magic number. The second hint told you the magic number is 5, and that 5 played a crucial role in working out all other numbers. And the third hint, which was a bit misleading because it was next to that large message. So you said, I thought we might need to rotate the message, but it was nothing to do with that. All 3 hints were telling you how to work out the number system. The third hint was rotate left. Now, I don't want to go into this in detail, but yes, in essence, there are only 4 unique symbols here: 1, 2, 3, and 4. Every other number there can be made up from those 4 symbols. And I didn't make up this number system, by the way, so I'll mention where it comes from in a minute. So you obviously know the symbols 1 through 10 because you can work them out from the equations. And having deciphered the hints, you go 1, 2, 3, 4, and then you rotate 1 90 degrees to the left to get 5. 6 is just 5 plus 1.
Yeah.
And 7 is 5 plus 2. 8 is 5 plus 3. You get to 10 and you take 10, 2, and you rotate it. You add 1, 2, 3, 4. You do that all the way and you end up being able to create 24 unique symbols, or 25 includes 0. You cannot, using that methodology, create a 26. It's impossible. At that point, you have to throw 2 digits together. Just as we do with binary and hex. Once you reach the limit of your base number system, you start adding digits together. So that gave, and I'm really curious to see how the students got to this. And it's actually a number system which was invented by someone back in 1990 for a computer game called Riven, which was a sequel to Myst. If anyone played, they were sort of solo adventure games back in the days of early PCs. And I solved this all on my own without understanding what base number systems was when I was about 13 or 14, without access to the internet, because my dad would shout at me if I tried to use the 14K dial-up modem. And I had no idea what a base number system was. And I look back now and think, I was using a base 25 number system and didn't realize it. So that gave them the number system, and then it would allow them to solve the equation that appeared on the page with the Caesar cipher. And I'm interested again to see whether this throws students, because what they what they obviously get, if we just take this single 2 digits over the right-hand side, we know that's the symbol for 2, and there's one of them. But this next column has a weighting of 25.
Yeah.
So it's the number 15, but because we're a base 25 number system, we've gone 125. So that has a value of 375, meaning that number in base 10 deanery is 377. And being a base 25 number system, these numbers get big pretty quickly. Column 1 has a value of 1, then 25, then 625. And actually, this is a 4-digit number. The most significant bit has a value of 15,625.
Can you go back to the numbers a moment where you were showing that how the numbers were all calculated?
Are we talking about that one?
Yeah, that's right. Yeah. Oh, you have got. Yeah. I wasn't looking carefully enough. I thought, oh, he said it's a base 25 number system. Did he include the number 0? Of course he did. Of course he did.
Yeah.
Yeah.
So it's a bit of a mess, because this number on the left here is actually 30,182, which of course in a base 25 number system we can store in just 4. Let's call them digits. And of course, that's why we often, and we say this is why we teach hex. What's the importance of hex? You know, people often use hex colors when they're doing graphics design. FFFFF is black and 00000 is white.
It's the other way around, but yeah.
Oh, sorry. Thank you, Dave. Why do we do that? Because to write it in binary would be a pain. It would be 4 times longer. And this is
and the same with MAC addresses, and the same with memory addresses, and anywhere where you've got large binary numbers, just expressing them in binary would be ridiculous. So, because 4 bits can be expressed in 1 digit of hexadecimal, it makes sense to basically only have a quarter of the size of the number if you're using hexadecimal. So this is kind of rooted in computer science, but it is kind of sort of cryptography at the same time.
Exactly. It was a bit more problem logical, but based. That's right. And just to show you, a massive number can be stored in 4 characters or 4 pictographs here, when we've got 25 values being able to represent by any one. But if they crack that, they did the sum, which is across the top of the screen. The sum ends up being 391 minus 377, and they get 14. Combine that with the picture of Caesar, and now they have the little nugget, Caesar cipher of 14, or Caesar shift of 14. That's effectively what that whole number system and that gives you. So they've got a Caesar shift.
I think out of the whole challenge, that might have been the bit that stumped me, actually. I reckon with enough time and concentration, I probably could have got to this point. But just that picture, I don't know, the obvious is the bit that would have confused me there. Because you had to say, oh, it's Caesar. Oh, right. See, of course, as soon as you said Caesar, I instantly knew it would be a Caesar cipher, because that's just a classic,
And this, again, is why I'm really interested to get the kids on, students. The teacher might be like, hang on, I recognize these symbols from my childhood. I played a game called Quick Bit of Googling, and you can find this is the Jin number system. It's the race in the game, and they work off base 25. As we know, different civilizations through history have used different base number systems. So you've got Caesar shift 14, and actually once you've got that, you're right, that's most of the puzzle cracked. The rest probably falls into place. You've got a very big message, which if you decode, if you decode, gives you what appears to be a set of directions. Starting at Verilon Manor, follow the road west to a small town of Tambury, follow the river, and you're like, hang on, this is the map. This is a set of directions for the map. So off you go to your map. I'm not sure if I actually have the map on this slide, but lo and behold, you head off to the map, you follow the instructions you've been given, and you end up in a particular grid reference. The grid reference happens to be E5. Just going to escape that. Yes, indeed. You end up at E5. Once you get to E5, there you go. That's the... just put that full screen. E5, because as you spotted, Dave, this matched exactly with the map. So E5 gave you this weird string of characters. And the first thing they'd probably try and do is shove that through the same translation squiggles they did before.
Yeah, that would be my plan. Yeah.
If they do, it gives them garbage.
Right, of course it does.
Because they haven't
Applied the Caesar cipher.
The Caesar cipher. That's where that comes in. So
you've got to shift it 14. Okay.
Exactly. And as soon as you do, let's just have a look. There you go. So there's the original message, smartrevise.craigandave.org/random string of characters. And it's Caesar ciphered into this, which is then encrypted into that. So the whole upshot of that entire process is another web address, and that web address, I'm hoping these students will believe, will take them to a screen that tells them, well done, you've solved.
Is that the end?
The cryptic challenge.
Oh, that is the end.
And when they get there, this happens.
Alpha level tests passed. Candidate shows potential for Omega program. Processing. Candidate promoted. Commence Omega challenge protocol.
That's not the end.
No. What they get told is they've passed the alpha level tests, and they, oh dear, I don't know why I find this so fun. They pass the alpha level test and they get promoted to the Omega level test. That formally concludes part 2 of the challenge and launches them into part 3. We won't carry on from there today, but just to show you, as with the previous time the mysterious man popped up, there's no further instructions on that video other than telling them you haven't yet won. But there is, as before, there's a crossword at the bottom there. I think what we'll probably do is pick that up next week and then explain the rest of the challenge. So yes, and again, I'm curious to hear from the students and the teachers. Were there moments of there's more? Did they? Because one thing they've obviously shown is great perseverance. There's still 2 substantial challenges left, multi-part challenges, which we'll get into next week. But they obviously, and isn't that one of the skills that we've said over and over again, above all else? I think Mark, our lead developer, mentioned it weeks ago in Smart Revise, and that young lad we had on Jack Rafferty, perseverance. Jake, yes.
Yeah, absolutely. I think when all is said and done about computer science, I think the most important skill you can have is perseverance. And if you look back in history, to the history of computer science, I think all the people that have been successful in the industry, right from the very early years, whether that's Alan Turing, John von Neumann, whoever, all the way up to the modern day, I think the one quality that they have is perseverance. They just don't give up. They just keep going and going and going, knowing that there is a solution out there, knowing they can be successful. And the only thing that's stopping them being successful ultimately is their own dedication. And I think for me, that's often the most frustrating part teaching computer science, is that students think that I'm some kind of genius, and I'm really not. I've got very mediocre GCSE results. I've got extremely mediocre A-level results. I've got mediocre degree level results. I only started to excel when I actually got into the world of work. And I realized at that point, too late for my own education to a certain extent, but I realized at that point that I needed to apply myself. And when I applied myself, I could achieve so much more. And so I think I don't regret any of that, because I can obviously share these stories with the students, and I think that makes me a much richer teacher, having experienced lots of failure in my own life. But I think, it is about that dedication, that perseverance. And the one skill I want to instill in all my students is just give it a go and keep going and keep going. And don't recognize when you're not immediately successful that is failure. And I'm really intrigued, actually, Craig, watching students play computer games. Because computer games, you're not successful. But that's the whole point of them, right? It doesn't matter whether it's kind of games from back in my day, whether it was sort of Manic Miner and Space Invaders and those sorts of things, or whether it's, the most recent games that, have just been released. they give you the sense of failure because you keep failing over and over and over again. But there's something about them that keeps bringing you back to try again and try again and try again. And then you get those little rewards and incentives. And ultimately, you know, what do you get from either finishing a campaign in a computer game or coming top of the table in a multiplayer, or, you know, whatever it is? What do you actually get from that? And the answer is nothing. The only thing, you don't get anything tangible, really. The only thing you really get is perhaps a few trophies and your own sort of self-pride that you kind of kept persevering until you beat it, whatever that thing was, whether that's other players on the other side of the world, or whether it's, you know, the program that the programmer had written. But what you've done to be successful is one simple thing: you've persevered. So if you can do that in a computer game, why can't you do that with Python? That's really my question.
Because it's not as fun, Dave. But it can be. That's the thing, isn't it? It's and oh god, I'm going to sound really old now. Some may argue, rightly or wrongly, there were far less distractions in the digital world when I was at school, when you were at school. You know, the plethora of social media apps, touchscreen tablets and phones, and hundreds of channels. There was much less distraction. I buried myself at 10 and 11 in that BBC Basic, learning Basic. I loved it. If I'm being all honest, would I have done that today if I was 11, with the access to the constant bombardment of multimedia and streaming services and consoles and games and tablets? So it has made it more difficult to inspire students when you're up against triple aims on the PS5 and Xbox, which are probably more fun than Python. Oh, you're learning Python. So it is tricky. We are in a different age, and there's a lot more, I guess, distraction is what I'm saying. There's a lot more distraction to take your mind off things. So, but I still see highly successful students all the time who find the passion for it, and, you know, they solve it, they hit a problem, and instead of giving up, they persevere. They try something new, that doesn't work. They try something different, that doesn't work. They go away, they come back, they try something, it works. And that moment, I did that. It's gold. Oh, look at me reminiscing.
Yeah, that's it.
True.
So as Craig's already said, you can do these things in your classroom, and we are going to make these cryptic challenges available to teachers so that they can use them in their own classrooms. We'll have to refactor some bits and pieces to make it work in a sort of non-website approach, but we'll do that. But, you know, teachers out there often say to us, how do you get students enthusiastic about computer science? And when we were talking to Karen Morris about getting more girls into computer science, it was about lots of subtle messaging all the way through that computer science is for them. That's really the message that you're trying to get across right from an early age, rather than seeing it as something that they can't do, that it's not for them. And just having a little bit of fun, as Craig says, and working with the students, and, you know, put a little clue to something somewhere in your classroom, and just don't ever talk about it, you know, and just see what happens. And if it goes weeks and weeks and weeks and you're getting frustrated because the students aren't doing anything with it, then just say to one of your students, have you noticed that thing up in the classroom? And just kind of, you know, a student that you know is going to kind of be intrigued by that kind of thing, and just sort of say, that's interesting, isn't it? And just kind of walk away and leave it, and just sort of watch what happens with a small group of their friends. And I think that's absolutely fantastic. And that's the kind of things the crazy things we do in our classrooms.
Yeah. And rightly or wrongly, it is our job. We're not saying all the time. We get tired. We're coming to Christmas. We all have our own lives. It is exhausting profession, but, you know, it is your job to find those ways to inspire students out there. And sometimes now we do have to go that little bit further, because if there are more distractions in kid lives, rightly or wrongly, we live in the society we do, with access to a vast array of multimedia. So it is our job occasionally to turn things on their head and don't be afraid to experiment. You know, either with new ideas. Some will work, some won't, but the students will really, really appreciate it. Right, I think it's probably a good point to leave that there then, Dave. So we're going to come back next week and finish off the Cryptic Challenge. And then I think we plan on having the actual winners on. So we can hear how they didn't follow my plan at all and they hacked it all. And I don't know what to expect from that. Well, thank you very much, everyone. We'll join you next week when we will finish off walking through the Cryptic Challenge. Bye-bye.